بسم الله الرحمن الرحيم. أهلا وسهلا بكم جميعا في هذه المحاضرة. First of all, I would like to welcome you all in this lecture, and I would like to thank the AI community and especially Dr. Fatima Ba'uthman for organizing this event and for the invitation. And thank you all for being here today. My name is Adel Sulaiman. I am an assistant professor at Najran University in the College of Computer Science and Information Systems. Also the Vice Dean for Quality and Development and the Dean of Deanship of E-Learning. So today I will be, it's my pleasure and honor to present to you the virtual and augmented reality, a glimpse into the future. In this, I will share with you my experience in this field in the past few years. So first we will go in the introduction. What's VR, history of VR, technology of VR, AR, jobs and skills, market size, challenges, research and resources. This is to give you an introduction if you are not aware of this field or what's going on in this field. At the end, I will share with you my experience and present to you a research project that I worked on in my graduate school. First of all, I think you have heard about virtual reality in this conference many times, but the idea is you will hear about virtual reality, augmented reality, mixed reality, extended reality. All of these names are coming between this scale. When we go in the left, in the real environment, where you have completely real environment, and then add to this right is the virtual environment where you are surrounded with the graphics all over. So something in between, here we have the augmented reality, where we are trying to augment the reality or the area that you are in with some graphics to make it interesting, to make it helpful. And you are still here aware of what's going on around you. If you are going to augmented virtuality, you can walk in completely graphical environment. If you are in virtual environment, you are isolated from your real world and you are completely in virtual environment. I hope this is giving you idea where we are. All devices are running on this scale. So if we go to the history, I will try to give you an idea about the history of VR. So as any emerging technologies, start with the fictions and then a research lab trying to improve the idea or to make it reality. And then we have 1968, the head-mounted display as a prototype. After that, we have the flight simulations and remote travel experience. After that, we have the PTSD therapy, which is stress disorder, and people can use it for a therapy on that demand. After that, you can see the gap here around 10 years. And then the big names jump into place: Google, Oculus Rift, HTC Vive, Sony, Facebook. All of these are changing the VR AR industry. So if we're talking about technology as devices, you will see different shapes and there are reasons for that. Google are providing this as an affordable for everyone to pay $10 and get this device and try it to get the sense of VR and what's going on in these apps. If you see PlayStation is changing now to VR, and it's interesting experience if you tried that. As well as companies are trying to find a way for navigation and VR, because this is one of the challenges. You have a small room, how to do infinite navigation and walking. There is also a web VR where people are working to transform the web that we have now to 3D. browsers and programming languages are there to also improve this situation. Looking at AR, also some promising technologies. Microsoft HoloLens in the second edition now. Magic Leap also is coming to place. And we remember the Google Glass, but these are the examples that's right now. In terms of software,
دكتور آسفين نقطعك، بس بدهم الشاشة تكون كبيرة إذا تكرمت. الحضور بيطلبوا إنه الشاشة تكون تتكبر إذا ممكن.
طيب. Let me see if we can do that. What about that?
Yeah, much better. شكرا.
Okay, very good. So in terms of software, people used to do code code every single thing. Now there are companies trying to bring a GUI and graphical user interface to have it easier for people to develop apps for these devices, like Unity game engine is making that easier for people to interact and learn how to develop apps for these. So you can see how companies here trying to solve the different problems. First is the price. These companies trying to bring the price down to be affordable by people. Also the size and the size of these devices, as well as keeping the resolution, field of view, keeping that resolution as high as possible. And you can see how challenging is that. So if you are trying to develop a VR game in your PC, it's going to be hard, especially if you have a large scale environment, or if you are trying to produce a high resolution graphic. It's going to be heavy. It needs a lot of computational power. It requires also a lot of processing. So the solution is using the cloud. But what about latency, connectivity, reliability? All of these are issues with the cloud right now, and 5G is coming to solve all of these issues and creating more affordable VR and AR to both consumers and developers. VR, AR in COVID-19. People thought it's gonna be 1 month or so, and it's taking longer, unfortunately. And people need to go out of that lockdown somehow. So they start using VR in different domains, job training, higher education, e-commerce, events and conferences. And one example is provided by Spatial, where they are trying to create this platform where users can upload their pictures and create an avatar for themselves and interact with their colleagues in a virtual meeting. A very interesting experience. And it also has some potential in the future. Introduced earlier by Facebook 2016 with a similar idea. So if we go to global VR market share, we see 50% in the commercial side, consumer about 30%, the rest go to enterprise, healthcare, and aerospace. If you are looking into jobs, you can see from 2014 up to 2017 and so on, you will see the jump in this number of jobs. Information, manufacturing, science and technical services, those are the three domains. So what they are looking for: software developers, user experience design and user interface design to put human in the center of these technologies, game engineers, sound engineers, artists, all of these are needed as the jobs in the VR industry. If we look also in software engineering interviews, you can see between 18 and 19 how VR, AR compared to other tech industry getting the highest. In terms of innovations and patent, you can see how VR, AR is growing year after year. In terms of companies, Microsoft and Samsung are the highest in terms of patent and innovations in VR, AR. The market size in US dollar or in billion US dollar from 6.1 to 18.8. And the reason why I'm showing all of these stats is to give you the idea how VR, AR is growing over years in different domains. If we look at research, research is going on, is very active in the academic community. If you go, most universities have their own labs and groups working day and night to improve VR, AR technologies. And they are working in hot area of research such as cyber sickness, which is one main issue. If you try this VR, AR and the first time, you will get dizzy. Some people get headache. It's getting worse with some people if you spend more time there. But on the other hand, people trying to solve that. The issue there is it's related with engineering. It's also related to the psychology. It's not one discipline you can fix and that's it. How people also perceive these graphics and how people interact with it is another area with the user experience. Sound, special companies and research labs only focus how to make the sound applicable in the 3D environment, hardware and security. I was surprised to hear that there are a group working in the security, how to make the VR environment secure, and they are investigating the question of what if we get hacked in the virtual environment? What if you have augmented reality glass and you get hacked? What's this consequences and how to prevent that? So here is an interesting research. It's not only with human, animal also get involved in the research, and they are trying to. This lab is saying that they have an increased milk production as a result of giving the cow VR environment with the summer view, and that's interesting research. Another interesting research is, I'm going to show you this research, but let me give you an introduction before that. This lady has a daughter with 4 years old. She died 3 years ago, and they are trying to create an avatar for this girl and try to create a scenario to interact between the mother and the daughter. And the way they did that, they collected videos and pictures for this girl and tried to create an avatar and create the scenario. Interesting project, and I will let you take a look. Okay, so and you can see how emotional that was. If you see this, you will get emotional. So you can imagine the mother in that situation, and also she knows this is all made up, but she gets immersed in that environment and forgets about the real world and starts thinking in a different way about her daughter, and that's amazing. This research got a lot of discussion about the potential of VR and AR use. One also interesting thing about this is it's not only one field working in this. It's a lot of researchers from different fields working together to make this happen. So if we talk about VR in Saudi Arabia, We are talking about different labs and academic programs. For example, we have the visualization lab in KAUST, as well as master programs in different universities, as well as research groups also in different universities working on the VR, AR researches. In the business wise, there are also outside companies coming to the US, big names like Zero Latency coming to Riyadh with entertainment applications. Also, there are some startups in the country in the domain of VR, AR, and also in the educational technologies. The VR, AR also introduced to students in the STEM education by educators and students to explore this area and use it also in education. A lot's going on about VR, AR in the country. The government also invested a lot of money in VR, AR technologies, such as Magic Leap with about $500 million in Magic Leap, and also in different companies in VR and AR. And one interesting group, they created a virtual reality app for the Kaaba, for people to experience the Kaaba in Ramadan while the lockdown in COVID-19. The app got successful and very good reaction by the user. This is just to let you know about VR in Saudi Arabia. There are also some things that I didn't mention here, but it's promising and has a lot of potential in the country in different domains. So what are the challenges for the VR in general? The social impact. So we are seeing now how we are interacting with our phones. People are talking about your average hour and our average hours you are spending in your phones, 3 hours, 5 hours, 6 hours. So what about if you get these amazing technologies and you get immersed in these technologies, spend long hours in there? So what's going to happen in our families and our social impact? And is there isolation, addiction? We don't know what's going to happen. Human sensory limitations, cyber sickness, as we talked about, and people now trying to solve that issue, even though the reason behind it, it's not very clear and it's not easy to solve. Virtual crimes, user privacy, it's also, as any emerging technology, when we are trying to, when we talk about data and collecting large amounts of data from the user, location, images, etc. So what about privacy? The price now of these devices still above average for the average people to get these devices and to spend that much of money. Also, if you are trying to make it wireless and a lot of effort in that side, batteries are another challenges. So this is the introduction, and if you would like to learn more about VR, how to develop VR, get certified in VR, you have Unity Learn and Unreal online learning. You can learn more. MOOC courses in Udacity, Coursera, Udemy. King Khalid University have their own MOOC courses in Kiki UX with game development course. You can join and learn more. The VR book is very interesting, comprehensive, updated book. I went to IEEE VR and we met the author for 3 hours. He summarized this book for us, and the book is very nice. He summarized 200 pages of scientific research in VR and AR and try to simplify it in this comprehensive book. I really recommend this for anybody to start in the VR industry. So as well as the IEEE VR, it's very nice community. They are meeting every year in different places of the world. I went there twice. One of them, I was a student volunteer there. This time in 2017, it was in LA, University of Southern California. Amazing institution with state-of-the-art applications and devices. You will also meet with scientists around the globe, and the student and the research community build the relationship. Also, you learn about the recent topic and on the area. So as a student, you can go as a volunteer, or as a researcher, you can publish there and visit. So you remember this slide. So amazingly, we are done with all of these. I try to make it fast just to save time for the research project. Now I will let you about my experience and virtual reality application center at Iowa State University, where I did my PhD there with Dr. Stephen Gilbert and Liz Miller to do a research and training and evaluation in a large-scale virtual environment for a location-based mobile application. Let me simplify that. Is we are trying to simulate part of the city in this large-scale simulation, and develop a mobile app to interact with this environment. So that's the idea of the project, and we will go to a detail. The Virtual Reality Application Center is a unique lab from the engineering perspective and the team perspective. They have what they call is the interdisciplinary team, where you have research group from all over the university: engineering, education, psychology, computer science, all working together in this research center to produce interesting projects. So the idea, we start by developing this app, and the idea of this app is to perform location-based functions. Like you visit this location and you navigate by GPS to this location, and then you perform certain tasks. So you go to the real world and do that, and that's okay. The app is working fine. But as an HCI, human computer interaction researchers, they didn't believe in that until you test that on user. So unless you said you bring 60 users, 80 users, 100 users, and bring the result and the statistic, quantitative and qualitative results, otherwise that's not gonna work. So we are trying to bring people to test this app, okay? But we are in the Iowa State, 3 months or 4 months of snow, and minus 15 to 20 Celsius. You cannot go outside. Safety of bringing people outside, physical effort, you will have them walk 2 miles, time, how to evaluate the app, how to control the environment, how to train people on that app. So all of these are challenges to test this app. We said, okay, can we create a virtual environment to do the same job as the real world? Can we bring the real world in the virtual environment and solve all of these problems? So we said, why not? We have the mobile application ready. We need to start building the virtual environment, and then we need to find a way to link between those two. Interestingly, we have at the VRAC, we have a unique lab called the C6 lab. It's in a tornado shape. You can notice it's beautiful from the engineering standpoint, and it's in the middle of Howe Hall at Iowa State University. And the idea of it, it's a room about 6 meters by 6 meters on each side, and they are trying to generate high resolution graphics on that room from each side. So how did they do that? They are putting very huge projectors in every side of the room, and these projectors are run by a cluster of computers, about 50 PC running together to generate these graphics. Interestingly, they were able to produce pictures from also the roof and the ceiling. And you can notice how did they do that here from the roof and the ceiling. They bringing a mirror, huge mirror here, where the projector will reflect that image, and the same from this side. And that's what makes this lab is a unique lab from engineering standpoint. You will find in some universities two-sided, three-sided, four-sided, but having six-sided lab is a unique situation, and that's very good for us as a researcher to get access to this lab. Now we have a similar idea in KAUST. We have C6 lab also called Cornea lab in KAUST, and it's a higher resolution than the C6 lab with 200 million pixels, more pixels, and updated devices in the KAUST lab. So by looking to the area that we are trying to simulate, you can see we call this, it's part of the city with many blocks in there, and we call it the training area. And this is the testing area. And we are trying to simulate the training area and move it to the virtual environment. So how to do that? Different ideas coming to place. First of all, is to go to every house in the city or in that part of the city and try to draw it house by house. And you can see this is impossible to do. Another idea is to fly a drone and generate high resolution videos and images, trying then to transform all of that to 3D models. We try to start that effort, but unfortunately, the area that we are in is close to the airport. We have drone flying restriction in on that area. So that didn't go well as well. So at the end, we tried to build a model using Google Map and SketchUp to draw the exact same layout of the environment and bringing these houses as a models at the same location. For example, this house at the exact same location in the real world, this house as well. You will find a similar layout outside with all the details in there. This model is also geolocated. What I mean by that is if you put, if you go to this location, you will find the latitude and longitude for that place exactly at the same thing that's in the real world, which is very important. I will let you know why later. After we are done with modeling this in SketchUp, we move it to Unity. Unity is a game development engine. You can, after you are done with this model, transform it to Unity and make it interactive and have more control of the movement and navigation. You can also add more effect of the environment. Now the environment is running in our PC and it's in a good shape at this stage. So the next challenges coming in our way are these three. First of all, how to implement that in the C6 lab, and then how to navigate in the lab, and then how to implement the GPS in the C6 lab. You can see every one of these need time and effort to figure out how to do it and implement it. So we managed to implement the environment in the C6 lab, and that looks beautiful. We had problems with the latency and the resolution, because this is huge graphics and the area is about 2 miles by 2 miles. It's huge environment with a lot of details and graphics that make it hard for the outdated devices here to manage. We try to implement some solutions, packages, remove some details from the graphics to have it move slowly and problem solved here. We move to the navigation in the lab. The navigation usually done here, you have a controller in your hand and you go right and left, and that's easy. We need in this project to free your hand because we need you to hold the mobile app in your hand instead. So how to do that? We try to remove the controller to the glasses, where this glasses is talking to these sensors up here. You can see these sensors, and you don't need a controller anymore. You can move using these glasses. And you can notice here, we have a dead zone. If you go to in this dead zone end of the lab, you will have a complete stop. If you want to increase your speed, you will get closer to the wall, and you will get higher speed as you go to close to the wall. And these are paper walls, so I had to ask participants to be careful of breaking these walls. So if the user wants to perform some task or slow down, they will go back and they get training for that to the dead zone and problem solve in navigation. So the problem now of GPS, yes, they have the sign in the streets to read and go navigate, but that was hard to do. We need to find a way to implement the GPS and the C6 to have a complete simulation as the real world. And different ideas, but we came at the end of this idea. If you are in this area of computer science or something, or in technology, you know what I mean by these names here, like database and log files, etc. But I will try to simplify it. This is the C6 lab, and this is the mobile app. We introduce a web server here. And the mobile app has a map with geolocation information and a log file. And the C6 lab also, you remember, we said it's the model is geolocated also, and sending where you are to this database. The mobile app is reading from this database every second, reading your movement, and problem solved. We have a GPS live and updated every second. So if you are standing here, that means you are in this position, and it's live every second. And if you move, you will have a GPS that will help you to dive all of this area in the model. And at this stage, we are happy with the project, where most of problems are solved. And now I will show you a demo of me walking in the environment. And you will notice a lot of things that I mentioned, especially the navigation and the movement. Please take a look, and we'll be back. You can notice how I do the navigation. I increase my speed by going closer to the wall. When I need to slow down, I go back. And if you pay attention to the sound, we try to also add sounds in the background to give you you are really outside. So you can see I can cross over this tree, but an interesting experience. And this is what you see from behind the camera, but if you see through the glasses, you will see a much better resolution, and it's very nice experience. And the first impression of users coming to this is, if they see it the first time, they say, wow. So that's interesting. Some of them get motion sickness. I had to stop the experiment in the middle for 2 participants out of 60. Also, interestingly, some participants, when they came closer to these trees, they lower their head. They get immersed in that environment, imagining it's a real tree. So they forget they are in the virtual environment. Also, when they try to cross the street, they look around for cars. So that's also interesting to notice that. From the research perspective, I was taking notes of all of that reaction and try to investigate that. At the end, we forget sometimes where is the door. So because we forget about ourselves inside the locations and directions. So from the research perspective, you can see here we are trying to do many things from the user perspective and psychology and human-computer interaction, and also from interacting how people interact with the mobile location application, as well as how people interact with the virtual environment, and at the end how people interact with the mobile app inside the virtual environment. And from the research perspective, this is a rich environment to investigate. This is the study procedure and more academic. I will not spend much time here, but you need to try people in VR and then in real world and compare between them, doing the same thing. That's the idea of if you are doing this kind of research. And then you go out and test them, how they perform, and you do some questionnaires to evaluate that. Also, we have ways of evaluation, quantitative evaluation, like errors and times, etc. So let me go to the evaluation. Now, you will see people, this is people in VR, and this is the group in real world. We are talking here in the training session in terms of errors. So people in the real world have less errors than the people in the VR, even though this is not at a significant level from a statistical standpoint, but still people in the VR. And we can understand why people in the VR are trying to figure out how to deal with the app and then how to deal with the virtual environment. They may have more errors. When we go outside for testing, still the same. People coming from the real world, they have also less errors, but also it's not at significant level. So errors is still going okay. If we look at time people spend in VR and outside, training and outside is less time, and testing as well. People in VR spend more time training and testing as well. This is not as at a significant level as well. Interestingly, look at the distance. So people in VR spend less distance. They take the app, follow the GPS from A to B, that's it. But people in VR spend significantly larger distance. And that's interesting, and big discussion in the group why that's happening and how to solve that. When they go outside, still the VR is more, but also it's not a significant level. But why this is happening? We try to investigate that. You remember we have a log files recording everything in the VR and in the real world. So we try to take the log file and visualize the path for people in the real world and VR. And you can see people in the VR, in the real world, we give them the app. They start from A, follow the GPS, straightforward, go to point B, easy. And then C, D, etc. And then they manage. If we come to the virtual environment, it was interesting to see the visualization of that. First, they start from here and then get lost as a first experience, trying to figure out their way. Even they have a GPS. They get familiar with the environment, try to follow up, getting to this point, and then trying what's next. You can see this is costing more distance in here. And then when they go to the location D, also they spend extra distance in here, as well as here compared to this location, and then at the end. Why this is happening? We propose many idea why that's happening. Maybe the speed of the virtual environments. People forget to slow down. That's why they get this extra distance. Also, some solution is to make the dead zone larger, so you can stop while performing the task and save this distance. That's why we get this large distance. From the satisfaction questionnaire, VR and real world, and you can see a scale of 7. It's still very close, and overall people are satisfied with the application, and they thought it's giving them the learning that they need to learn about the task and about the application. So we gave people at the end space to express their opinion about VR and real world. After collecting that, we find more negative comments about real world and more positive comments about the VR. We cannot conclude from this, hey, the VR is better, but it's giving you a sense of how people are satisfied with the real world, and it's good to see that result. In the usability of the mobile app, we try to quantify that by calculating the tap. Every single tap or click you made in the app, we calculate that. And then if we go to training, people in the VR interestingly made less taps inside the environment. Maybe that's due to they are busy with the virtual environment. They didn't interact more with the mobile app. People outside made more taps. But when we go outside for testing, things are changing. People in VR are doing more taps, maybe because they are in a new environment, and people in the real world, so they get the idea of it, so they know it, but still all of that is not as a significant level. But this is to give you a way how people interact with the mobile app in different environments. The usability questionnaire, overall satisfaction score, VR higher a little bit, but very close, not at a significant level. System usefulness still VR, but still close. Information quality and interface quality, interestingly, it's very close in interface quality. If we look at the end, this is, I'm about to conclude here, the interaction with the virtual environment, many ways to evaluate that and different questionnaires and etc. But I will give you one of these things that we did. It's called the presence questionnaire. Basically, the presence means the feeling of being there. Evaluating your feeling of being in the environment. So you can see in the realism, we got 13 points, 72, which is very good. And then sound, people were able to recognize the sound of the environment, quality of interface. And then these are the list 3, possibility to act, to examine, self-evaluation. So that telling us that people need more control of the virtual environment, even though we get high realism and sound in this scale. In summary, the idea of this project is to introduce the interaction between mobile app and the large-scale virtual environment, and to evaluate that interaction. Also, we conclude that presence, usability, and spatial ability for people also important when designing large-scale simulations. Limitations: low number of participants. We get around 60. People usually do more participants is better. The more you have, the better your results. Long time and walking effort outside. Low spatial ability, and this is a psychology concept. We are trying to get low spatial ability people to compare between low and high, but that was not easy to do. Technical issue in the cave, C6 and the mobile app. Sometimes we bring the user, everything is ready, but one of these 50 devices is not working, everything is down. So that's another issue we are having, not having a control group, because that will make also require more users, and also will make the study more complex and will take more time for users. Future direction: we are looking to find a statistical method that allows to prove statistically that those two environments are equal. We are still working on that. Also, we are trying to improve the navigation in the cave to close the distance gap that we show you. Many ideas in that direction, and we are working on that also to make this available in HMD devices. It's easier and more accessible than the C6 lab. This is Dr. David Martin. He is a city council in Ames. He came to visit us and see how can this app help the city. And interestingly, he grew up in that area, and he has a house, or he has a house there, and he was able to show his house and houses of his neighbor, and we were happy about that. That means our environment is, he was able to recognize that in our environment. He's also a computer scientist, PhD as well. Our project got the best poster presentation award at Iowa State University on the graduate level. At the end, I would like to thank all of you for listening and for your time. Special thank to the Artificial Intelligence Society, to the Saudi Mobile Show Committee, as well as our colleagues and professors at Iowa State University at the Virtual Reality Application Center Lab. Thank you, and please, if you are interested in this area, you can contact me for research collaboration, for any question about this presentation, or in the VR, AR area. Yep, that's all.
Thank you very much, Dr. Adel, for such an interesting lecture, very innovative, and lots of scientific work has been involved in this. We are proud of you. The society is interested, of course, to join future work and research with you. And it seems that, mashallah, very advanced work that you've been doing as an extension for your PhD work. And I think there is great opportunity also for different application, as you have mentioned, for Saudi Arabia and future implementation. Out of your experience, what do you think the future of AR, VR would be in Saudi Arabia? Thank you.
Thank you so much, Dr. Fatima. And that's an interesting question. We are part of these technologies going in the global level. So we can see how the mobile applications or mobile devices start, and now it's going everywhere. I think we are having the same idea in the AR, VR, especially with the big companies jumping on the game. I think Apple is working now in AR glasses and other big tech companies. So if they provide a solution, you will find everybody is working as a VR developer, and they are trying to buy it and to use it, to engage with it. If you find yourself, everybody around you is using VR, so you find yourself in the middle of it without even noticing that. So in terms of in Saudi Arabia, I'm seeing a lot of potential, for example, in the academia, in terms of research. If a lot of universities can communicate together, researchers can also collaborate with the international community on that. That will be very good. Also, if we can introduce the interdisciplinary research, that's very interesting to our universities, because now as a computer scientist, you cannot solve the problem by yourself. You need a psychologist, you need an engineer, you need an education people. So if we can also move to that direction, it will be a great opportunity. From business standpoint, startups has some potential also in the entertainment, especially entertainment games and platforms, business as well for training. We saw how even medical doctors have been trained for COVID-19 using VR and AR technology. So a lot of potentials, and I think great people working on that demand, and having people like and scientists like Dr. Fatima leading the effort, bringing people together, starting these conferences and these initiatives. We will be in a bright future, inshallah. Yep.
Inshallah, we would be, and I'm sure that we can do lots of work, and you can lead also with us in virtual reality and augmented reality. There is lots and lots to be done in this area. Thank you very much, Dr. Adel. We are really proud of you.